In this video, we're going to take a look at section 10.2 and 10.6 on triangles and right triangle geometry. All right, a triangle is a geometric figure that has three sides, and it has to be closed. So it's closed up, three sides, which makes it have three angles. The sum of the measures of the three angles of any triangle is 180 degrees. So the three angles have to add up to 180. So one type of problem you're going to see on the homework is, here's a triangle, you have two of the angles, find the measure of that third angle. So you know that all three of these angles have to add up to 180. So what you might do is let the unknown angle be represented with the letter X. So remember, we were doing that back in Unit 1 with word problems. If you have an unknown value, you let X represent that unknown value. And then we'll add to that the other two angles, 120 and 17. And according to this, it's not a definition, it's not a theorem, I don't know what you want to call it, but according to this rule, the three angles have to add up to 180 degrees. And then you just solve that equation for X. So that's what we're going to do here. Let me create some more room. So I meant to have the calculator up and running. So let me go ahead and get the calculator. All right, so we're going to take 120 plus 17. It's going to give me 137, so we'll combine these together. And then we're going to subtract the 137 to the other side, and we will get that the missing angle is 180 minus 137. So this is a little trick that I learned back in school. I'm subtracting those backwards, right? So it should have been 180 minus 137, but I already had the 137 in my calculator. I didn't want to have to retype that in, so I just left it there and subtracted 180 off of that. So my answer is positive 43. So even though my calculator is saying negative 43, it's the right number, it's just the wrong sign because I subtracted them backwards. So, which saves you a little bit of time. So we're going to get 43. So the angle of, how should I say this? The measure of angle A is 43. Right? So that missing angle is 43 degrees. Okay. All right. Let's take a look at the next topic we have. So anytime you're dealing with triangles, you probably can reasonably expect to encounter one of the most famous formulas in math, the Pythagorean theorem. All right, now this theorem relates the lengths of the sides of the triangle to each other, as long as the triangle is a right triangle. So a right triangle is a triangle with one 90-degree angle. And that's indicated here by the little box notation. So that angle there is a 90-degree angle, which we call a right angle. A triangle cannot have two right angles because two 90-degree angles would add up to 180, and you wouldn't have any degrees left over for a third angle. And all triangles have three angles, right? Because they have three sides, they have three angles. If you have one right angle, if you have one 90-degree angle, that is called a right triangle. And in the case of a right triangle, the three sides, A, B, and C, are related by this formula here. A squared plus B squared equals C squared. Now, C squared is actually, it's a distinct side of the triangle. It's the side that is opposite the 90-degree angle, which is also called the hypotenuse. So in fact, when I was in high school and learned this formula, we had what I think is a better formula than this. We had A squared plus B squared equals H squared. That's what I had in my textbook. And I like that distinction because A and B, it doesn't matter which one's which. But C, that has to be the hypotenuse. So rather than call it C, which just makes it look like all three are just interchangeable, right? If you call it A, B, and C, it's just like, it doesn't matter which one's which. But C actually does matter. So I actually like calling that H instead for hypotenuse. So that one has to be the hypotenuse. The other two sides are just the two other legs of your triangle, and it doesn't matter which one's A and which one's B, right? So let's take a look at an example. We are being asked to find the third side of this right triangle. So notice it is a right triangle. I don't know why C is there. I don't think that's supposed to be there. It's a right triangle. So the three sides of this triangle are related by the formula a squared plus b squared equals, I'll just use c squared because that's what they're using in the diagram. Again, we have the two legs here, but it doesn't matter which one's A and which one's B. I was just going to go ahead and call this one A and this one B, but if you had in your mind the other way around, that's perfectly fine. It doesn't matter. So I'm going to let side A be 12, side B be 9, and I'm looking for side C, which is the hypotenuse, right? Which is going to be the angle, or the side that's on the other side of the equal sign. I don't even know why I said angle right then. Right, so A is equal to 12, B is equal to 9, and C, the hypotenuse, which is the side opposite the 90-degree angle, is what I'm looking for. So I'll just leave that in as my variable. So again, I'll use my calculator. We need 12 squared, which you might know these off the top of your head. I guess I'll just come over this way. 12 squared, which is 144. And so I don't have to pull it up again. 9 squared, right? 9 squared is 81. So we'll have 144 plus 81 equals c squared. We'll go ahead and add those two together. Right, so we'll have, we've already got the 81 on the calculator, so I'll just add to that the 144. And I get 225. So these numbers were very carefully chosen, so this would work out nice. We get 225. And then to find the value of C at this point, we have to get rid of that power of 2. And I don't know that we've had this conversation in this class yet, but what cancels out a power of 2 is a square root. So I will apply the square root to the C squared. That square root will cancel out that power of 2, and I'll just get C by itself. But if I take the square root of the right-hand side, I have to also take the square root of the left-hand side. So I get the square root of 225. So you should use your calculator to figure that out. Now, you know, this one, the notation is kind of weird. So if you have a calculator that you own, you probably have better looking notation than this. And it might work different than how my calculator is going to work. So I think my square root button is, I can't really point to it, but it's right next to the x squared, right? That's the square root, and it has a 2 there, which is kind of weird. Your calculator probably won't have the 2. It'll just have the radical symbol. And probably in your calculator, you'll want to push that button first, and then type in the 225, and then hit enter. But this calculator works backwards, so we would want to type in the 225 first, and then hit the square root button, and it takes the square root of the number that's in there. But your calculator probably works the other way around. Do the square root button first, then type in 225. Either way, the answer you should be getting is 15. So if you're not getting that answer, you're not typing it in correctly. So we get 15. So that is the length of the side of the hypotenuse of this triangle. All right, let's look at this next example. Now this time, they give me the hypotenuse, right? So here's the 90-degree angle. The side opposite the 90-degree angle is the hypotenuse, which is going to be my value for C. That has to be C in the formula a squared plus b squared equals c squared. C has to be the 13, right? So 13 has to get plugged in here. A and B, again, doesn't matter which one's which. I guess since they're already using A to represent this side, I will let B be the side that we have the number for, which is 5. So I'm going to plug in 5 for B, and then I will have to solve this for A. Now, this is going to work out a little differently than the previous one. So we're going to square both of these. We'll get A squared plus 5 squared, which is 25. And then 13 squared, let's just go ahead and do that on the calculator. 13 squared is 169. Okay. Then, to get A by itself, instead of adding those two numbers together, I'm not going to take 25 plus 169. To get A by itself, I have to first start by subtracting the 25 to the other side. Right, so I guess I'll just continue the work over here. So we're going to get a squared equals, and we're going to take 169 minus 25. So 169 minus 25 gives me 144. So again, the numbers are chosen for this to work out nicely. And then, just like we did last time, to cancel out the power of 2, I will use a square root. If I do that to the left-hand side, I do the same thing to the right-hand side. The square root of 144 is going to be 12. Of course, you can do that in your calculator, but you could also just recall this, right? A square root is basically doing a power of 2 backwards, right? So if I have 144, undoing that power of 2 gets me back to 12, right? So it's the number that when you square it, it gets you the 144. And we see over here the number that when I square it, that gives me 144. That just sounded really weird to me. So the number when squared that gives me 144 is the number 12. So that's what the square root is equal to. All right, let's take a look at the next example. So if construction costs are $150,000 per kilometer, find the cost of building the new road in the figure shown below. So again, that new road is our hypotenuse, right? It's the side opposite the 90-degree angle, so that has to be C. It's not labeled for me this time. So the previous 2 examples, they were nice to label the sides A, B, and C. This time, you have to realize the new road, the side you're looking for, is your hypotenuse, which needs to have the label C in this formula. A squared plus B squared equals C squared. So what I'm looking for is C. A and B, it doesn't matter which one's which. I'll just call the bottom one A like I did before, and the side one over here B. So I'll plug those numbers in for A and B. So I'll have 4,000, which is a pretty big number, squared, which is going to make it even bigger, plus B, which is 3,000 squared, and that's going to equal C squared. So this one, could I do this off the top of my head? Let's see, 100, yeah, so I think it doubles the number of zeros. So I'm going to double check just to make sure I'm thinking of this right, but 4 squared would give me 16. And then we have 3 zeros. Now when you square a bunch of trailing zeros, I think they just double. Like 10 squared is 100, right? That goes from 1 0 to 2 zeros. So I think this is going to go from 3 zeros to 6 zeros. But let's just double check that just to make sure I'm thinking of that right. So 4,000 squared, we get 6 zeros. Okay, very good. Same thing's going to happen on this one. 3 squared gives me 9, and then the zeros, I'll just double those because that's what happens when you square. And we get this. I'm going to add these together, so we'll have 16 plus 9, which is 25. And then we'll have the 6 zeros after that. But again, you can use a calculator if you're feeling uncertain about that. Now, to get C by itself, just like we did on the previous 2 problems, to cancel out the power of 2, we're going to apply a square root to both sides. And so that will give me C. Again, a shortcut here, the square root of 25 is going to be 5. And this is going to do the opposite thing, right? When you take the square root, it's going to cut the number of zeros down to half of what they were before. So we have 6 zeros there. When I take the square root, it'll get cut down to 3. And so we're going to get 5,000 as our value for C. So this road will be 5,000. So, I didn't realize they were going to try to trick us like this. This is in meters, right? So if you follow the units, you have meters here for 4,000, and you have meters for 3,000. Now, when you square those, you actually get meters squared, right? So when I add these together, this is in meters squared. Sorry, I should use a different color there. Let's try that again. All right. So this will be in meters squared. But when you take the square root of meters squared, it comes back out again in meters. Now, the reason that matters is because, this is not our final answer. So if this is a problem on the homework, and you go to type this into my math lab, that's not going to be the right answer. It's going to be wrong. Even though we did everything right so far, we're not done, right? It's asking not how long is the road going to be. It's asking, find the cost of making that new road. And the cost of making these roads is $150,000 per kilometer, right? So I didn't realize they're going to try to trick us here on these units, right? So the answer I'm getting is in meters, but the cost I'm given is in per kilometer. So we have 5,000 meters. I need to convert that to kilometers in order to use this to figure out how much it's going to cost, right? So 5,000 meters, if you remember, we talked about this in chapter 9. We take the decimal. Because we're going from a smaller unit to a larger unit, we're going to move the decimal to the left. And if you go check that chart, the metric system chart that we had last week, which I gave you a handout for, you'll see that kilometers is 3. You have to move up the table 3 to get to kilometers from meters. So we want to move the decimal 3 times, and we're going to end up getting that this is equivalent to 5 kilometers. And each of those kilometers is going to cost us 150 grams, right? So we're going to have to multiply that by 150, right? And again, you can follow the units on this to make sure that everything's working out the right way, right? We're going to multiply this by 150,000. This is dollars per kilometer, right? And that way, if you think of this as a fraction as being over 1, you see that the kilometers will cancel out, and our final answer will be in dollars. And what we want to do is multiply these together. So we'll have 5 times 150,000. Let's go ahead and grab the calculator to do that. So 5 times 150,000 is going to give me $750,000. Whoops, I forgot I had that there. $750,000. And that will be our final answer. So that one had a lot of surprise twist to it, right? So not only do we use the Pythagorean theorem, we get our initial answer, but we have to realize that is not the final answer, right? The answer you get from the Pythagorean theorem is not the answer you're looking for. It's just a piece of information you need to get the answer that you're looking for, right? But not only is it not the final answer we're looking for, it's also not in the right form. We have to take the answer we're getting from the Pythagorean theorem, convert the units to the units that we need in order to calculate our final answer. So a lot of extra hoops to jump through on that problem, which made it kind of a fun problem to do. Right. Okay. So next topic is trigonometry. So this one's pretty interesting. Trigonometry means measurement of triangles. I guess that's what the literal translation is. Trigonometric ratios, let A represent an acute angle. So notice that's a capital A. So we're letting A represent these angles here. And lowercase a represents the length of the side opposite of that angle, right? So angle A is over here. The side opposite angle A is the lowercase a. And lowercase a represents the length of that side, right? We have angle B right here. The side opposite angle B is represented with a lowercase b, right? Okay, so if you're looking at angle A, it turns out and this is only true for right triangles, so just like the Pythagorean theorem only works for right triangles, these trigonometric ratios only work on right triangles. The angle is related to the ratio of the sides of the triangle. So there is a relationship there, and the relationship is I don't know how I want to say this, like trigonometry is the relationship between the angles and the sides of the triangle. And there's different relationships. So the relationship between, let's say, side A and the hypotenuse, so remember this is the hypotenuse here, if we take a ratio of those two sides, it's related to angle A by this trigonometric function called sine, right? So the sine of angle A will equal the ratio of those two sides. So the way we describe that formula, to make it easy to remember how the sine of an angle is calculated, is that the sine of an angle is equal to the length of the opposite side, which is what this is talking about here, right? A is the side opposite of angle A, divided by the hypotenuse. So the sine of an angle equals the opposite over the hypotenuse. That's how I learned it. It's a little more wordy down here, but the words are still there. it's opposite over hypotenuse. That's how you get the sine of an angle. And that's how those two sides are. I should say it like this. That's how the ratio of those two sides are related to the angle, to angle A, right? It turns out that also there is a relationship between the ratio of this side and the hypotenuse, right? Now this side is said to be adjacent to the angle that we're looking at, right? So if we're looking at angle A, B, the length B, not capital B, but lowercase b, is the adjacent side to that angle. C is still the hypotenuse. So if I take the adjacent side to the angle divided by the hypotenuse, that ratio is related to angle A through the cosine function. Right. So cosine, which is abbreviated COS. Right. So the cosine of that angle will equal the ratio of the adjacent side to the hypotenuse. So again, a way to remember that formula is that the cosine of A is adjacent over hypotenuse. That's how I remember that. Lastly, we can also relate the opposite and the adjacent sides together. So far, both of these ratios are connected to the hypotenuse, but there is a trigonometric function that connects to the ratio of the opposite side and the adjacent side, right? So if I take the opposite side, which is lowercase a, and the adjacent side, which is lowercase b, and I make a ratio of those, that ratio is related to angle A through the tangent function. And so we get this formula as well. And so that's going to be, again, the way I learned it was tangent is opposite over adjacent. And to tie all that together, there is an acronym that is fairly memorable, SOHCAHTOA. SOHCAHTOA. So it looks like this. So, I'm saying that wrong. It should be A. SOHCAHTOA. Right. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So if you can remember this weird sounding word, you can remember all three formulas at once. SOHCAHTOA, however you want to pronounce that. Okay, so let's put this into practice with some examples here. So on the next page, we have some examples. So this says, find the sine, cosine, and tangent of angle A, right? So capital A is the angle. We want to find sine, cosine, and tangent. So the sine, again, so even though the full spelling is S-I-N-E, it's kind of silly to abbreviate, right? Because it's only 4 letters. But when we write it out in mathematical formulas, we abbreviate it to S-I-N. The sine of angle A from our previous page is opposite. So maybe I'm going to write out, I was going to put just O, but I'll go ahead and write it out. Opposite over hypotenuse. Right, let me make sure I say that right. I'm skipping a letter here. Hypotenuse. Right. Okay, now for angle A, the opposite side is given to us as 5, right? So we have that piece of information, but the hypotenuse, remember, has to be the side opposite the 90-degree angle. Here's the 90-degree angle. The side opposite that is blank. And so you might think, well, there must be a mistake. They accidentally left that number off of the problem. But they didn't, unfortunately. They expect us to calculate it, right? This is C, and they want us to calculate it using what we just learned earlier, which is the Pythagorean theorem, right? So I'll let this be A, I'll let this be B, and it doesn't matter which. Now you might say, well, shouldn't A be the opposite side of angle A? It doesn't matter for the Pythagorean theorem which one's A and which one's B. So I'm going to plug in 12 for A, plug in 5 for B, and that way I can find what C is equal to, and that will be my hypotenuse, and then I can answer these questions about sine, cosine, and tangent. All right, so this is going to be 144 plus 25, which is going to be 169. And then when you take the square root of both sides, again, they're being nice here, the square root of 169 is going to be 13. So I have to calculate this hypotenuse from the other two sides, and I calculate it to be 13. And so that's my hypotenuse. Right? So this is, for angle A, this is the opposite side, this is the adjacent side, and 13 is going to be our hypotenuse. So for the sine of A, it's going to be the opposite, the length of the opposite side divided by the length of the hypotenuse, which is 13. And that's it. That's our answer. And so I assume on the homework, this is probably what you would type in right here, right? 5 over 13. Don't write that as a decimal, just leave it as a fraction. Now, cosine, so again, SOHCAHTOA, right? Cosine of angle A is going to be the adjacent side divided by the hypotenuse. The adjacent side is 12, right? The hypotenuse is 13, and so that would be the cosine of A, right? So cosine of A is 12 over 13. Now, I don't know what angle A is equal to. We could find out. Like, from this equation here, we can solve that for A and find out what that angle is equal to, but we're not doing that yet. We are actually going to do that later, right? And then tangent, right? So I've run out of room. I guess I'll just jump over here. I don't want to lose the graphic because we need those numbers. The tangent of angle A is going to equal the opposite over the adjacent, right? SOHCAHTOA, right? So the end of that's TOA. Tangent is opposite over adjacent. The opposite, the measure of the opposite side is 5. The measure of the adjacent side is 12. Right? So we get tangent of A would equal 5 over 12. So we have found sine, cosine, and tangent of A given the numbers that are in this diagram. Find A in the right triangle here. So this is lowercase a that we're looking for, right? Which is going to be a length. And it's going to be this length here. Now you might say, okay, if I want the length of one of the sides of this triangle, I'll just use the Pythagorean theorem. But you can't, because you only have the length of one side of the triangle. If you want to use the Pythagorean theorem, for example, to find B, right? To find A. If I'm looking for A, I know B is 150, but I don't know C, right? I'm also missing that value. So you can't use the Pythagorean theorem to find A here. What we can use is this angle, right? So I'm looking for A. So let me erase this circle here. I'm looking for A, and I know B. So given those two sides, this is the opposite side, and this is the adjacent side to the angle I was given, right? So I'm given angle A, which is 40 degrees. Now I could calculate this one if I wanted to, right? Because this is 90, that's 40. This one has to be 50 degrees, right? So I could also use that angle if I wanted to, but again, that's an extra step that we don't have to do. So I'll use the angle that I'm given. Based on that angle, I'm looking for the opposite side, and I know the adjacent side. So the trigonometric function I need to use to calculate A is the one that relates the opposite and the adjacent to this angle here. And only one of those trigonometric functions relates those three things together, and it's the tangent, right? The tangent of angle A is equal to the opposite over the adjacent. Sorry, I keep writing that. Funny. Okay. So tangent connects all three of these parts together. It connects the angle to the opposite side and the adjacent side, which is everything that I'm working with here. So that's the formula I need to use. If I was looking for C in this case, for example, then I could use the sine, right? Because, or I could use cosine, excuse me, because I'm given the adjacent side, and if I'm looking for the hypotenuse, what relates the adjacent side and the hypotenuse to the angle? That would be cosine in that case, right? So the formula you use is based on what you're looking for and what you're given. Right, so we'll plug all the numbers in that I've been provided here. So the angle is 40 degrees. So I'll plug that in for A, right? That's the angle. The opposite, I don't know. I'm calling that lowercase a, so I'll just stick with that as my variable. And then the adjacent side is B, which is equal to 150. Right. So that's my formula. I plug the numbers in, and I have a variable remaining, and that variable is the variable that I want to solve for. So I want to get a by itself. The way you get a by itself is you get rid of this 150 by multiplying 150 to both sides. All right, so I'm going to multiply 150 to both sides of the equation. That's going to cancel out the 150 from the right-hand side, and I end up with 150 times the tangent of 40 degrees, which I will need to use a calculator to compute, and it's probably going to be an awful decimal answer. That's what I would expect, right? So you will need a scientific calculator to do this calculation. Right now I have my calculator on standard mode, so I'm going to have to switch it to scientific mode. And that should give me some trigonometry functions. So it's a drop-down menu right here. Right? So here's sine, cosine, tangent, secant, cosecant. So I actually had it backwards. Sine, secant is the opposite of sine, cosecant is the opposite of cosine. Looks like that's how they have it set up. It's been a while since I've done trigonometry, so I'm sorry I'm a little rusty on that. Okay, so we want to type in 150 times, so I'm going to have to do this backwards actually, sorry. I'm going to have to do the tangent part first. So I'm going to type in 40 again. Your calculator, you should just be able to type it in exactly how you see it on the screen. 150 times tangent of 40. You just want to put the 40 in parentheses when you type it in your calculator. But for me, this calculator, the interface, you type in the angle first. Let me just clear that 150 out. Type in the angle first, then you pick the trigonometric function. So this will take the tangent of 40. So you see that's what it's done here, which is 0.839. Hopefully that's in the right mode. So one thing you do have to be careful about is there's two different modes which you can use on a calculator for doing trigonometry. One is the degree mode, which is what we need here because this is 40 degrees. But there's another mode called the radian mode, which we're not going to talk about because it's not relevant to the examples we're doing. But you want to make sure your calculator is in degree mode. I guess mine is because it has DEG here, so I assume we're in degree mode. And maybe that's what that little circle means next to the tangent, that it looks like a degree symbol. So I think this should be the right answer. Then we want to multiply that by 150, right? And so I'm going to get 125 point, I didn't see what the decimal was. Rewrite that 5. 125.86. I don't know how many decimal places what am I saying WebAssign for? I don't know how many places my math lab's going to want from you. But just make sure you round it to whatever the directions say on my math lab. That should be the answer that you're getting from your calculator. I feel like I just want to double check it. I have a scientific calculator here, so let me just double check it on mine. So again, on my calculator, I'm going to type in 150 times tangent of 40. Maybe I could just show you. Actually, I could probably bring it up on the screen here so you guys can see what it looks like in the calculator. So right here. Okay, sorry, it's upside down. Let me fix that. Okay. So let me type it in again for you. So 150 times tangent of 40. All right. So that's how you should be able to type it into your calculator. Hit enter, and we get the same answer there, right? 125.86. So if you're not getting the answer of 125 point whatever we just got, you might be in the wrong mode. So to switch it from degree mode, to switch it to degree mode, on this calculator, it's this DRG button. But if you have a different calculator, you're gonna have to, there's a different button you're gonna have to find. And here you can see that when we click that, it has degree mode, radian mode, and I'm not even sure what GRD stands for. But so if radian mode is highlighted, you need to switch it back to degree mode for it to calculate the answer correctly. So I just wanted to point that out. So, okay. Okay, find the measures of the parts of the right triangle that are not given. Round all answers to the nearest whole number. So we want to find everything out about this triangle that we can. Let's start with the angles first. Again, this is a 90-degree angle, so that's known. We know what that is. Oh, now I see why C is here. That's the angle. I didn't even think about that. This is 57 degrees, so we know that one, but we don't know the angle the measure of angle B. So we can find that like we did at the very beginning of the video. We know all three angles together have to add up to 180. So let's just call this angle X here. So we have X plus 57 plus 90, and we know that has to add up to 180 degrees. By solving this, we will find the measure of that missing angle. Right, so 57 plus 90 is going to give me 147. And then we will subtract the 147 to the other side to solve that for X. And so we're going to get 33, I believe, right? So 33. So that would be the measure of angle B, right? So that's one thing that they want us to find is that missing angle. We want to find the lengths as well. So that's one piece of information. We want to find C and A as well. And again, we can't use the Pythagorean theorem yet because you have to have two of the sides in order to use the Pythagorean theorem. We only have one side, right? We only have the 48 yards here. So we're going to have to use a trigonometric function to find one of these sides, and then we could use the Pythagorean theorem to find the third side. Right, so I'll go ahead and start with the angle I was given. So we'll use angle A. We have the adjacent side to that angle. I'm writing my letters backwards here. Adjacent side. And we are looking for, we could look for either one, but let's say we're looking for the opposite side again. Right. And we have the angle. So we need the formula that relates the angle to the opposite and adjacent side. That's going to be the tangent formula again, just like in the last problem. That's going to be opposite over adjacent, right? So we're going to plug in the numbers we were given. We have, I'll just do it over here, tangent of 57 degrees equals opposite. We don't know what that is. We're calling it A, so we'll stick with that, over the adjacent, which is 48. And now we're going to solve that for A. We do the same thing we did in the last problem. We're going to multiply 48 to both sides. And we'll get 48 times tangent of 57 degrees equals A, right? The 48s here cancel out. We're going to plug this into our calculator. Since I got my nicer calculator out, sorry I didn't do that earlier. I should have been using this all along. Let me go ahead and show you how to do that on here. So we have 48 times the tangent of 57. I already know I'm in degree mode, so the answer I get from this should be the correct answer, which again is not a nice answer, unfortunately, and that happens a lot with trigonometry. So we have 73.9. I can't remember, what did it say to round to here? Let's scroll back up. We want to round to the nearest whole number. Okay, so 70, what did we say it was? 73.9, that's going to round up to 74. All right, so I'll just put 73.9 here. I'll try to. 73.9. We're going to round this to the nearest whole number. That's going to round up to 74. Right. So that is the measure of side A. It's about 74 yards, right? It's the same units that we have here, 74 yards. Now we can calculate the hypotenuse using the Pythagorean theorem, right? So let's go ahead and do that up here. And I'm going to try to zoom out so we can just kind of get a helicopter view of everything that we've done. And maybe I'll just try to organize this a little bit better for you, right? So here was the work we did to find angle B. Here's the work we did to find side A. And now to find side C, we will use the Pythagorean theorem. A squared plus B squared equals C squared. Now here I'm not exactly sure what we should do, because we're going to round our answer to 74 when we type it into my math lab. But we really don't want to round it during our calculations. So I actually would recommend going back to, and I might say we should use a couple of extra decimal places just to be safe. So I'm going to say, I'm grabbing my calculator, A, I'm not going to call that 74 because that's rounding it off a little too much, I feel like, at this point. We'll call that 73.9135, right? Let's just keep a few decimal places there. And then when we get to the end, we'll round it to the nearest whole number again. B is 48, so we're going to plug that in for B. and then we're trying to find c. Right? So, in fact, if you want to be smart about it, I mean, on paper I'm rounding it, but in my calculator, I still have the whole number there, right? So I don't even have to round it. I'll just keep the number that's already in my calculator. And what I want to do in the Pythagorean theorem is raise that to the second power. So I'll just hit power, like square it, and it'll take that previous answer and raise it to the second power. So that way I'm not even rounding it off at all. It has all the decimal places there. I'll hit enter. So that's what you get when you square that. Plus 48 squared, right? And I end up getting this number here. So 7767.2, right? Which I, again, will just keep in my calculator. So 7767.2 equals c squared. And now, to get c by itself, we take the square root of both sides, and we get c equals. And again, because that number is still in my calculator, I can just avoid rounding it at all. I'll just take the square root of the number in my calculator. But this one's a little tricky because I have to type in the square root symbol first, and then type in the number, and I don't want to have to type all those digits out again. So what I'm going to do is do square root, which is that button right there. And to tell it that I want it to use the previous answer in my calculator, I use this button right here. For my calculator, it's right above the negative sign button. It says ANS, which stands for answer, and it tells the calculator to use the previous answer. So I hit second, because it's the second function of that button. I hit second, and then that button, and that says use the previous answer. I'll close the parentheses, and it's going to take the square root of the previous answer. Try to enter, and we get 88.1, and that way it keeps the calculation as precise as possible up until this final moment, right? So we're going to get 88.13, and there's some more to it than that. Now this we want to round to the nearest whole number as well, and because that's a 1, we're going to keep that as an 88. If I didn't keep the precise numbers through this, then I might have gotten something a little different. I might have gotten like 88.5, right, which is not much different, but it would be enough that I would round it up to 89, which would actually be the wrong answer. So that's why you have to be careful about how much you round. So it's okay to round your final answer, like right here, but when I'm doing a further calculation, go back to the decimal answer and use a more precise number rather than the rounded number. Right? And so this will be 88, and I think that we found everything, so which is what we were asked to do. Okay, use the inverse trigonometric keys on a calculator to find the measure of angle A rounded to the nearest degree, whole degree. Right. So let me zoom in again so we can read those a little bit better. Right. So the inverse trigonometric functions. Well, let's just go ahead and do the math on this, and then we'll talk about where you find those keys on the calculator. So what we're looking for is angle A. Right. We want to know what that angle is equal to. What we're provided is the length of the side opposite that angle and the hypotenuse, right, which is the 50. Right. So we're interested in angle A. We're provided the opposite length and the hypotenuse length. So we have to find the formula that relates all three of these things together, right? We need to know the angle, which we can just call x. The opposite, we have the opposite side length and the hypotenuse length. The formula that relates all three of these together, angle, opposite, and hypotenuse, is the sine formula, right? The sine of A equals opposite over hypotenuse. So the angle, I don't know what that is, so I'm calling that x. So let's just call that sine of x, right? That's the thing I'm looking for. The opposite side of that angle has a measure of 30 meters, and the hypotenuse has a measure of 50 meters. Right. Now, what I want to do is solve this for x. Your first instinct might be, okay, if you want to get x by itself, divide by sine on both sides, right? So you might think that this would be a way to approach that. Unfortunately, that doesn't work because this is not multiplication. This is not sine times x, right? The example I will give in my college algebra class would be like this. If you were trying to solve this for x, let's say you have the square root of x is equal to 5. And you want to get x by itself here. Doing this would be like saying, let's divide by the square root symbol on both sides to cancel out the square root symbol, right? That's nonsense, right? Clearly, this has no mathematical meaning, right? A radical can't be empty, right? You can't just have an empty radical. There has to be a value inside that radical for it to make sense. Sign works the same way. You can't have an empty sign, right? There has to be something inside the sign for that to make sense. And there's nothing for us to put there that would help in this case. So that doesn't work. You can't divide by an empty sign on both sides, right? What we have to do is cancel out that sign, just like here, right? What you do to solve this for x is you cancel out the square root. You don't divide by the square root. You cancel out the square root by doing the opposite operation. The opposite of a square root is a power of 2, right? And so you square both sides. That square root cancels out that power of 2, and you get x is equal to 25, right? So we just need to know what operation cancels out a sign. Unfortunately, it's kind of an abstract thing. It's what's called the inverse sign, which is what the directions we're referring to. And we label the inverse sign in a pretty archaic, abstract way. It's just the same thing, sine, with a -1 exponent. Now, it's not a real exponent. It's just indicating that what we're talking about here is the inverse of sine. And if we apply an inverse sign to the left-hand side, we have to apply an inverse sign to the right-hand side as well. Right, so it's supposed to be a -1 there. All right. So this inverse sign cancels out the original sign and gives me x. And on the left-hand side, I have the inverse sign of 30 over 50, which we could have reduced, but there's no point. We're going to plug this into our calculator anyways. Right. So this is the answer I'm looking for, and I can get that answer out of my calculator. So let's go ahead and take a look at where you find that button on the calculator. Right? It's going to be, let me maybe zoom in a little bit more so I can see this. And so every scientific calculator should, sorry, I just keep butchering my words here. So every scientific calculator should have inverse trigonometric functions. And they're often located with the original trigonometric function. So you see we have sine, cosine, tangent. The second function on those buttons is inverse sine, inverse cosine, inverse tangent. So to access the inverse sine, you just have to push the second button and then the sine button. And that's going to how do you say, apply the inverse sign, right? Which we see in our calculator now, and it's notated exactly the same way. Sine inverse, right? And we want to take the sine inverse of 30 over 50, right? That's our fraction, and we close that. So that's all there is to it. It's just you got to plug it into your calculator, and we hit enter, and that gives us our angle, which is 36.86989. Blah, 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 blah. All right, so from our calculator, we get x equals 36.86989, and again, it goes on from there. The direction said to round to the nearest whole degree. I'm sorry, it's the weekend, I'm tired, and I already did one video for my other class, so that's why I'm really struggling to communicate now. I'm just kind of out of energy. So we want to round to the nearest whole degree. Because that's an 8, this is going to round up to 37. So that's what you'd want to type into My Math Lab. Okay. Let's take a look at, I think we have two more examples. So let's get these done. Let's zoom in here. So this one, we want to do the same thing. The directions aren't on the page, but it's basically like part B. It's the same directions for this problem. All right, we want to find the measure of angle A. This time, the information we're provided are the 15 degrees, which is actually not the opposite this time, it's the adjacent. and the 17, which is the hypotenuse. Again, we know that because it's opposite the 90-degree angle. So we need a formula that relates the angle, which I will call x, to the adjacent and the hypotenuse sides of the triangle. That formula is the cosine formula, right? That's going to be adjacent over hypotenuse. So I hope it's clear, I'm not getting to pick the formula I want to use. I'm forced to use that formula based on the information I'm provided, right? Just like on the previous problem, I didn't want to use sine. I had to use sine because I was given the opposite and the hypotenuse. That's what sine represents, right? That's the ratio represented by sine, so I have to use the sine formula. Here I'm given the adjacent and the hypotenuse, so the formula that applies here is the cosine formula. That's, adjacent over hypotenuse is represented by the cosine formula, so that's the one I have to use. If I was given the opposite and the adjacent, I would have to use the tangent formula because that's the only formula that relates to those two sides. All right, so here we don't know the angle, we're calling that x. The adjacent side is 15, the hypotenuse side is 17. I'm leaving a little space this time because I learned something from the last page. We want to apply the inverse cosine to both sides. So I left a little space to put that there. The inverse cosine cancels out with the original cosine, leaves me with x. And so on the right-hand side, I get inverse cosine of 15 over 17, which I will plug into my calculator. I will go ahead and demonstrate that for you as well. Oh man, I left my calculator over there. 1 second. Okay. So inverse cosine this time, so second, and the cosine button gives me inverse cosine 15 over 17, and that tells me the angle, right? So when you do the inverse trigonometric functions, you're using the ratio of the lengths of the side of the triangle to work backwards to figure out the angle of one of the angles of the triangle, right? And I'm sorry it's blurry. Maybe if I zoom out, it will refocus. But it's 28. That's not okay. 28.07, right? 28.07. They want us to round to the nearest whole number, so we're going to round here. Because that's a 0, we're just going to keep that as a 28, right? So the angle here, so I didn't say this in the last problem, just to make it clear, is 28 degrees. Now, when you type that into MyMathLab, you probably don't need to use the degree symbol, but I just want to make it clear. The number we're finding here is not the length of a side of the triangle. It is the angle of one of the angles of the triangle, right? Same thing here, right? This 37, it's not 37 meters, right? It's not a length. It's an angle. It's a degree, right? So what I found is that this angle here is about 37 degrees. That's the angle. And then with that, I could find the other angle if I wanted to, right? Okay, let's take a look at this last example and then we'll be done. A plane rises from takeoff and flies at an angle of 10 degrees with respect to the horizontal. So I think they're missing a word there with the horizontal. So it says a plane rises from takeoff and flies at an angle of 10 degrees with the horizontal runway. I think that they left out a phrase there. It's with respect to the horizontal runway. When it has gained 500 feet in altitude, and 10 degrees, find the distance to the nearest foot that the plane has flown. Right. So the distance that the plane is flying is this dotted line right here. That's the actual distance, the direct distance it's flying. The altitude is 500, so that's the height above the ground that the plane is. And the plane took off at an angle of 10 degrees with respect to the ground, right? So we have this angle, we have the opposite side of that angle, and we're looking for the hypotenuse, right? That's the thing we're looking for. So again, what formula relates the angle to the opposite side and the hypotenuse? It is the sine function, right? So sine of A equals opposite over hypotenuse. Again, it's not like I'm picking this one because I like this one over the other ones. I'm being forced to use that formula because it's the only formula that connects these three things together. So we know the angle this time, right? We don't have to use x for that. It's 10 degrees. So I can plug that in for the angle. Opposite is 500. The hypotenuse is what I'm looking for. I guess we could just call that C, right? We'll just keep calling that C. So there's my formula. I've plugged in what I know. I'm left with this variable C. I need to solve for that variable. So what I would recommend doing with this is cross-multiplying. You might say, well, cross-multiplying was, how do I do that here? We talked about cross-multiplying in Unit 1. I believe there was a problem like that on the test. Think of this as a fraction. Think of this as sine of 10 degrees over 1. Right? Now you have one fraction equals one fraction. You can cross-multiply to simplify that, right? So we're going to get sine of 10 degrees times C, right? That's multiplying these opposite corners together. And we're going to get 1 times 500, right? That's multiplying these opposite corners together. And we set those equal to each other. And then we get C by itself by dividing the sine of 10 degrees to the other side. Now this time we're dividing by sign, but it's not an empty sign like I talked about before. There's a number with it, so this is perfectly legitimate. It makes sense. It's going to resolve to an answer because we have a number that goes with the sign. Right? So we're going to have sine of 10 degrees. I just dropped the degree symbol, but that's going to cancel this out. So we have C equals 500, right? Because 1 times 500 is just 500 over the sine of 10 degrees. So that's what I want to plug into my calculator, and I'll find how far the plane has traveled at this point. So let me show you what that looks like in the calculator. So we'll have 500 divided by, not inverse sine, right? Just sine of 10 degrees. And we're going to get, the button's not working, 2,879.3852. Again, it's a decimal number. All right, so that's what we get as our distance, 2879.38. And again, it runs on from there. What do the directions say? Find the distance to the nearest foot. So we want to just round to the nearest whole number. And the distance is in feet. All right, so we have that here. So that's the unit of our answer as well. It's in feet. So in case it asks that on the homework. We want to round to this. We have a 3 here. That means we round it down, so it's going to be 2879 feet. All right, so that concludes section 10.2 and 10.6. Thank you for watching until the end of the video.